The geological heritage that the Canary Islands possess is of such dimensions and richness that the Spanish Geological and Mining Institute has proposed that the islands be declared part of the Geosites Programme, under the auspices of UNESCO and the IUGS, the International Union of Geological Sciences. There are a number of aspects about the geology of the Canary Islands that have influenced the Institute's proposal, aspects that can be considered unique and unusual in the context of world geology. One of these is that on some islands, such as Fuerteventura, La Palma and La Gomera, the rocks formed in the course of the history of these oceanic islands are very well represented, from their birth as seamounts on the seafloor to their transformation into islands. These rocks form the basal complexes of the islands. Our group seeks to establish the genesis of such rock formations, and also to gain an in-depth knowledge of the early destruction and formation processes of the insular volcanic edifices. The origin and evolution of the magmatism associated with the birth and growth of oceanic islands within the lithospheric plates is currently one of the issues generating a great deal of discussion and debate within the scientific community and those concerned with the study of genesis and evolution of the Earth's magmas. Inside the basal complexes of the Canary Islands, we can see on the surface rocks that were formed a long time ago on the seafloor, or when the islands were simply large seamounts. In all the basal complexes, we can see submarine volcanic rocks formed through quiet underwater eruptions that lead to the edification of submarine volcanoes. These are volcanoes that later emerged as the origins of the islands. When the submarine edifices were about to emerge, or had already emerged, the submarine volcanic rocks were colonized by corals. These corals then grew to form large reefs. Partially destroyed remains of these are visible in some areas of La Palma and Fuerteventura. Thanks to outcrops on the surface that form the basal complexes, we can get a glimpse of the heart of the colossal submarine and subaerial volcanoes formed on each of the islands. The solidification of magma in the magmatic chambers created by plutonic rocks of varying compositions, pyroxenites, cyanites, carbonatites, that form vast exposed bodies in the basal complexes of the islands of Fuerteventura, La Palma and La Gomera. However, the most distinctive feature of the basal complexes of the Canary Islands is parallel dike swarms that are made up of thousands of dikes. The dikes were the ancient magma feeding channels that passed through the edifices during their ascent to the surface. Sometimes the magma erupted, but at other times it got trapped in the cracks, gradually solidifying and giving rise to a dike. The dikes often appear in a vertical position and parallel to each other, and they represent the deepest parts of ancient volcanic dorsals. Thanks to the later dismantling of the tallest parts of these volcanic edifices, we are able to observe and analyze these rare dikes on the surface of the islands. But, without a shred of doubt, what's the most striking thing about these basal complexes is the question of how it was possible for rocks formed at such depths on the seafloor or inside large volcanic edifices to be visible on the surface several hundred meters above sea level. The main objective of the research that we are conducting is to clearly establish the origin of the different rock formations that appear as part of the basal complexes of the Canary Islands. The islands of Fuerteventura, La Gomera and La Palma, and possibly in Tenerife. These include sedimentary or volcanic sedimentary rocks, submarine volcanic rocks, and plutonic and hypoabyssal complexes. We also want to study the interrelationships between the island formation processes, mainly the magmatic agent, the state of tensions that affect insular edifices that are in part conditioned by the edifice's own weight, and the sudden destruction phenomena that represent the large gravitational slips in the first moments of the submarine formation and the emergence of the Canary Islands. In order to achieve the proposed research goals, it's vital to undertake a series of steps in which certain actions are performed. Firstly, we will undertake a review of available data and materials, articles in scientific journals related to the geographical areas or the topic of content of our study, samples of rocks in mineral collections, thin sections in petrographic archives, topographical maps, orthophotos, aerial photos, geographical mapping, and existing geochemical data. Secondly, we will conduct a detailed geological exploration in the area where the rocks that are the object of study are exposed. We will collect sedimentological and structural data, and we will examine the nature of contacts between different rock formations, as well as collecting rock samples. At the same time, we will also draw up geological maps. Once we move into the laboratory with the collected samples, we will complete a series of steps: separating and identifying fossils, examining thin sections of rocks under the microscope, analysing the chemical composition of rocks and mineral samples, isotopic analyses, absolute dating of the rock and mineral samples, and so on. Once we have completed our observations and data collection, we will go on to look at our data in depth and arrive at an interpretation. This interpretation will allow us to establish an evolutionary model of each of the insular edifices during their submarine development and immersion stage, to identify spatio-temporal patterns in the evolution of magmatism in the Canary Islands archipelago, and finally, to contrast the results obtained against the hypotheses that attempt to explain the origin of the archipelago. Lastly, we plan to present the results to the scientific community and society at large. For the scientific community, we will use the publication of specialized journal articles or conference papers. In society at large, we will be making people aware of the results through the creation of a website and through documentary films, books, and articles in the popular press. The Spanish strategy for science, technology, and innovation states that all research endeavours must include mechanisms that guarantee open access to obtain data, to publications, and also to the results of publicly funded research. In keeping with this, the results expected in the development of the project will be made available to all interested public bodies, since we believe that they will be of practical use and will have a range of applications, both by providing basic and general knowledge for the scientific and educational community, and by offering information about geological mapping, the petrological and geochemical description of rocks, information that is vital for any subsequent study carried out by the Spanish Geological and Mining Institute and the National Geographic Institute. These might include the preparation of geological, hydrogeological, geomorphological, gravimetric anomaly, and magnetic maps, and other public and private bodies might use our findings as data for environmental impact reports and maps, public work projects, hydrogeological research, volcanic hazard maps, and so on. In the future, our group would like to extend our research to include the basal complexes of the Cape Verde Islands, which are very similar to the Canary Islands from a geological perspective.